Hey there. Welcome to Module 1 of our course on Docker Compose. Today, we're going to dive into the basics and get you up to speed on everything you need to know. So, let's start with an overview of Docker Compose. It's a tool that allows you to define and run multi-container Docker applications with ease. Pretty cool, right? Next up, we'll talk about installation and setup. Don't worry, it's not as complicated as it sounds. We'll walk you through the process step by step. Now, let's get into the nitty-gritty of Docker Compose YAML syntax. It's basically a way to define your application services, networks, and volumes in a single file. Trust me, it's a game changer. And finally, we'll cover building and running multi-container applications. You'll learn how to bring all your containers together and make them work seamlessly. Exciting stuff. By the end of this module, you'll be a Docker Compose pro. So, let's get started. Hey there. So, let's dive into Docker Compose. It's basically this awesome tool that lets you easily handle multi-container Docker apps. How does it do that? Well, by using a YAML file to set up all the services, networks, and volumes your app needs. It's like your personal assistant for managing containers. With Docker Compose, you can start, stop, and scale your containers with just a few simple commands. It's super handy, especially for developers who need to quickly fire up multiple services. So, if you're looking for an efficient way to manage your containers, Docker Compose is definitely the way to go. So, picture this, you're working on a web app with a front-end server, back-end server, and database. Instead of going through the hassle of starting each container one by one, why not use Docker Compose? With Docker Compose, you can define all three services in a single YAML file. This file will lay out everything, from the image to the ports and environment variables for each service. And the best part? You can fire up all the containers with just one simple command, Docker Compose up. How cool is that? Alright, so before you can dive into using Docker Compose, you'll need to make sure Docker is up and running on your machine. For most folks, Docker Compose comes bundled with Docker Desktop for Windows and Mac OS, or you can snag it separately if you're on a Linux setup. Once you've got everything installed, you can double check that Docker Compose is good to go by typing in Docker Compose version. Now, getting Docker Compose set up involves whipping up a dockercompose.yml file in your project folder. This is where you'll lay out all the services and configurations for your multi-container application. So, make sure you take the time to define everything just right in that file. So, once you've got Docker Compose all set up, the next step is to create a new directory for your project. Inside this directory, you'll want to make a file called dockercompose.yml. This file is where you'll lay out the different services your application needs, like web, database, and cache. In the YAML file, you'll need to specify things like which image to use, which ports to expose, any volumes to mount, and any environment variables required. Once you've got all that set up, you can simply run Docker Compose up to kickstart all the containers listed in your YAML file. Easy, right? Hey there. Welcome to Module 2, where we'll dive into container networking and volumes in Docker. So, let's talk about container networking in Docker Compose. This is all about how containers communicate with each other. It's like setting up a virtual network for your containers to chat and share information. Next up, we have managing data persistence with volumes. Volumes are like special storage areas where your container can save data even if it's stopped or removed. It's like having a virtual filing cabinet for your important files. Now, let's chat about using Docker Compose networks to connect containers. This is where we bring all our containers together on the same network, so they can easily talk to each other and work together seamlessly. Lastly, we'll cover sharing data between containers using volumes. This is super handy for passing files and information between different containers, making collaboration a breeze. By the end of this module, you'll have a solid understanding of how container networking and volumes work in Docker. So let's dive in and explore these concepts together. Alright, so when you're using Docker Compose, you can set up container networking to let your containers talk to each other on the same network. Basically, when you fire up multiple containers with Docker Compose, they automatically join a default network that Docker creates. This makes it super easy for them to chat using their container names or service names. If you want more control over how they communicate or keep them separate from other networks, you can define your own networks in the Docker Compose file. This is key for making sure your containers run securely and smoothly. So, let's say you've got a web application with a front end and a back end. In Docker Compose, you can set up a network in your file to connect these containers. This lets the front end and back end communicate with each other without needing to open up ports to the outside world. By using container networking in Docker Compose, you make it easier for the containers to talk to each other and keep them separate from other networks on the same host. Pretty neat, right? Alright, so let's talk about volumes in Docker. Basically, volumes are like your container's way of holding onto data even after you shut it down or get rid of it. See, when a container goes bye-bye, any data inside it disappears too. But with volumes, you can stash that data outside the container on the host machine, so it sticks around even if the container is out of the picture. And get this, you can share volumes between different containers, so they can all play nice and work with the same data. It's a handy trick for keeping your data safe and sound in a container world. So, let's say you have a database container holding some super important data. What you can do is create a volume on the host machine to store all those database files. This way, even if you stop or get rid of the container, your data will still be safe and sound for future use. By attaching a volume to the database container, you're making sure that the data sticks around and can be accessed by other containers that need to work with the database. It's basically like giving your data a home outside of the container, so you don't lose anything when things get stopped or removed. So, using volumes for data persistence is key to keeping your important data from disappearing into the digital abyss. Hey there! So, Docker Compose is a pretty cool tool that lets you set up custom networks in your Docker Compose file. Basically, you can connect different containers together by specifying which ones should be on the same network. This helps you control how they talk to each other and keep them separate from other networks. It's super handy for building complex applications with lots of interconnected containers that need to chat. By defining networks in Docker Compose, you make sure your containers can communicate safely and smoothly within the same network. Pretty neat, right? So, imagine you have this cool microservices set up with different containers for each service, right? Well, in your Docker Compose file, you can actually set up separate networks for each service. This means that the containers for each service can chat with each other over the network, all while staying separate from containers for other services. By using Docker Compose networks, you're essentially building a super organized and expandable structure for your app. Each service gets its own little network to play in, and they can easily talk to other services when needed. This not only streamlines how your containers communicate, but it also keeps your app running smoothly. Cool, right? Hey there! So, when you're working with Docker, you can use volumes to easily share data between containers. It's like giving them all access to the same storage space. This makes it super convenient for different parts of your application to communicate and work together. By mounting a volume to multiple containers, you can make sure that any changes made to the data by one container are instantly reflected in all the other containers that are connected to that volume. It's perfect for situations where you have multiple containers that need to collaborate and share things like configuration files or logs. Just set up your volumes and watch the magic happen. So, imagine you have a web server container that's dishing out static content, and a logging container that's there to collect all the logs from the web server. Now, here's where things get interesting. You can set up a shared volume to stash away all those log files. By linking this volume to both containers, the web server can write logs to it, and the logging container can then swoop in, read those logs, and do its thing. This nifty trick lets these two containers team up seamlessly. The web server does its logging, and the logging container processes it, all without losing any data. It's like a dynamic duo in action. Docker's feature of using volumes to share data between containers is a game changer, making it a breeze for different parts of your application to collaborate and share information. Alright, in Module 3 we're diving into Docker Compose services. We'll be covering some important topics like defining services in Docker Compose, configuring services with environment variables, scaling services with Docker Compose, and handling health checks and dependencies between services. So, let's start off by looking at how we define services in Docker Compose. This is a key aspect of setting up your containers and making sure they work together smoothly. We'll also discuss how to configure these services using environment variables, which can be really handy for customizing your setup. Next up, we'll talk about scaling services with Docker Compose. This is all about managing the number of instances of a service running at the same time, which can be super useful for handling varying workloads. And finally, we'll touch on health checks and dependencies between services. Ensuring that your services are healthy and can communicate with each other effectively is crucial for a well-functioning system. So, get ready to learn all about Docker Compose services and how they can help you streamline your containerized applications. Let's dive in. So, when you're working with Docker Compose, you'll be using this handy little file called dockercompose.yml. In this file, you get to define all your services, which basically represent the containers running specific apps or processes. It's like giving each part of your application its own little container to live in. Within this dockercompose.yml file, you can really get into the nitty-gritty details. You can specify things like which image to use, which ports to expose, what volumes to mount, and any other configurations needed to keep your service running smoothly. And the beauty of it all is that by defining your services in Docker Compose, you're able to easily manage and orchestrate all these different containers that make up your application. It's like having your own little team of containers all working together seamlessly. Cool, right? So, picture this, you've got a web application with a front-end and a back-end service. In your Docker Compose.yml file, you'd set up two services, one for the front-end using something like Inks, and another for the back-end with an image like Node.js. You can define the ports to expose, set up volumes for storing data, and even add in environment variables so that the two services can talk to each other. It's all about making sure everything in your app can work together smoothly. Hey there. So, in Docker Compose, environment variables are pretty handy. They let you pass in different values to your containers on the fly. This comes in super useful when you're setting up your services for different environments, like dev, staging, or production. Plus, you can use them to keep sensitive info like API keys or database credentials safe without writing them directly into your code. Just pop those environment variables into your Docker Compose.yml file and voila! Your services become more flexible and way easier to handle. Cool, right? So, let's say you want to set up your database connection string in your backend service. What you can do is define an environment variable for it, which can vary depending on the environment you're working in. In your Docker Compose.yml file, you'll want to specify this environment variable by adding something like db_connection equals your_database_connection_string. When you fire up Docker Compose with the up command, the value of the db_connection variable gets passed to the container. This way, your backend service can easily connect to the correct database without any need to mess around with the code. Cool, right? So, you know when you're running a service in Docker Compose and suddenly you start getting a ton of traffic? It can be a real headache to handle all that increased workload, right? Well, that's where scaling services in Docker Compose comes in handy. By setting the number of replicas for a service in your Docker Compose.yml file, Docker Compose will take care of creating and managing extra containers for you. This means you can easily scale your application up or down without the hassle of manually handling each container. Pretty cool, huh? So next time your traffic spikes, just remember to scale those services in Docker Compose and let it do the heavy lifting for you. Easy peasy. So, let's say you've got a service that's getting bombarded with requests and you need to handle more traffic. No worries, you can easily scale it up by tweaking your Docker Compose.yml file. Just pop into the services section, find your app, and set the number of replicas to, let's say, 3. Now, when you fire up Docker Compose, it's gonna work its magic and spin up 3 instances of your app service. These replicas will then share the load of incoming requests, giving your application a boost in capacity without any coding changes needed. Pretty cool, right? Just a simple tweak and you're good to go. Hey there. Welcome to Module 4 all about deployment strategies. Today, we're diving into some cool topics like deploying multi-container applications to different environments, whether it's your local setup or cloud platforms like AWS or Azure. We'll also chat about continuous integration and continuous deployment, CI/CD, pipelines using Docker Compose. And of course, we can't forget about monitoring and logging strategies for multi-container applications. So, let's get started and explore all these awesome deployment strategies together. Alright, so when it comes to testing out multi-container applications on your own computer, you'll want to use something like Docker Compose. This handy tool lets you set up and run multiple containers right on your local machine. It's super useful because it lets developers check how their apps will work in a production environment before actually deploying them. By putting all the setup details into a Docker Compose file, developers can easily fire up all the containers they need with just one simple command. This really helps streamline the whole development process and makes testing a whole lot easier. So, imagine you're working on building a web application, right? Let's say you've got a front-end container with a React app and a back-end container with a Node.js server. Now, instead of juggling multiple commands to get them up and running, you can simplify things by using Docker Compose. With Docker Compose, you can easily define all the services, networks, and volumes needed for each container in one place. Once you're all set up, just type in Docker Compose up in your terminal, and voila! Both containers will start running smoothly. Now, here's the cool part, you can open up your browser and check out your application at localhost. This local deployment lets you test out all the features, spot any bugs, and fine-tune everything before taking your app live in a production environment. So, Docker Compose basically streamlines the whole process, making it super convenient for you to develop and troubleshoot your web app. It's like having your own personal testing ground right at your fingertips. Pretty neat, huh? So, When it comes to getting your multi-container applications up and running on the cloud, platforms like AWS or Azure have got your back. They provide all the infrastructure and services you need to host and manage those containers with ease. And here's where things get really cool. By using tools like Amazon ECS or Azure Kubernetes Service, developers can make the whole deployment process a breeze. You can quickly deploy and scale your multi-container apps in the cloud, tapping into all the awesome scalability, reliability, and security features these cloud providers offer. In a nutshell, it's all about using these tools to harness the power of the cloud and make sure your applications are running smoothly and securely. So, next time you're thinking about deploying your multi-container apps, remember to take advantage of what AWS or Azure have to offer. So, picture this, you've got a bunch of different services all neatly packaged into containers in your microservices setup. Now, if you want to deploy these containers to Amazon ECS, all you need is a task definition. This little document spells out everything from which containers to use, to how much CPU and memory they need, and even how they should be networked. And once you've got that sorted, Amazon ECS takes care of the rest. It'll do things like schedule your containers to run on a cluster of EC2 instances, handle load balancing, scaling, and monitoring, all automatically. This cloud setup is super handy because it lets you easily adjust your application scale depending on how much traffic you're getting. Plus, you can tap into other cool cloud services like managed databases and storage solutions. Cool, right? So, picture this, you've got your hands full with a multi-container application, and you want to streamline the whole building, testing, and deploying process. That's where CI/CD pipelines with Docker Compose come in. These pipelines automate everything from start to finish, using cool tools like Jenkins, GitLab CI/CD, or GitHub Actions. Here's the deal, you set up a pipeline that kicks into gear whenever there's a code change. This means that any tweaks or updates you make get tested and deployed without you having to lift a finger. Pretty sweet, right? And to make things even smoother, Docker Compose steps in to spin up all the containers you need for testing or building your app. In a nutshell, CI/CD pipelines with Docker Compose take the hassle out of managing your multi-container applications. With automation on your side, you can ensure that your changes are tested and deployed consistently and reliably. So, no more manual fussing around, just sit back and let the pipelines do the heavy lifting for you. So, imagine you're a developer working on a project and you want to streamline your deployment process. Well, you can set up a cool CI/CD pipeline that automates everything for you. This pipeline will pull the latest code from your repository, build Docker images for your app services, run unit tests, and deploy the updated containers to a staging environment. By doing this, you can catch bugs early, keep your app always ready for deployment, and save yourself a ton of manual work. And guess what? Docker Compose makes setting up these pipelines a breeze. It lets you define all your container configurations in a single file that you can use in different environments. So, with Docker Compose, you can easily manage your containers and make your deployment process super efficient. Cool, right? Alright, so when it comes to keeping an eye on multi-container applications, monitoring and logging are key. You want to make sure everything is running smoothly and efficiently, right? That's where tools like Prometheus and the Elk Stack come in handy. With Prometheus, you can monitor the performance and availability of your containers, while the Elk Stack, that's Elasticsearch, Logstash, and Kibana, helps you keep track of all those logs. By using these tools, developers can get a clear picture of how their containers are doing, spot any issues that pop up, and make sure they're using their resources wisely. It's all about keeping your multi-container applications reliable and scalable in real-world situations. So, don't forget to set up those monitoring and logging strategies to keep things running smoothly. Alright, so imagine you've got a bunch of containers running your application. Now, to keep an eye on things, you can use Prometheus to gather data like CPU usage, memory, and network activity. This data can then be visualized on dashboards to give you a clear picture of how your app is doing. But that's not all, you can also use the Elk Stack to manage all the logs generated by those containers. This means you can easily search through logs, filter out what you need, and even spot any errors or weird behavior. By setting up alerts based on certain conditions, you can get a heads up before any issues start causing problems for your app's performance. Keeping a close watch on metrics and logs is super important for keeping your multi-container app running smoothly in today's fast-paced, spread-out environments. Alright, welcome to Module 5 where we're going to dive into some best practices and troubleshooting tips for Docker Compose. So, let's start off by talking about the best practices when it comes to designing Docker Compose files. Now, when you're working with multi-container applications, it's important to know how to debug and troubleshoot common issues that may arise. We'll cover some strategies for tackling those pesky problems. And of course, we can't forget about security. We'll discuss how to secure your multi-container applications using Docker Compose. Lastly, we'll touch on some performance optimization techniques to make sure your Docker Compose applications are running as efficiently as possible. So, get ready to level up your Docker Compose game with these tips and tricks in Module 5. Let's dive in. So, when it comes to managing multi-container applications with Docker Compose, designing your Compose files is key. You want to make sure you're planning and organizing your services thoughtfully within the file. This means giving each service a clear purpose and defining its dependencies. Another important aspect is utilizing environment variables and volumes effectively. This will give your application the flexibility and portability it needs to run smoothly. And don't forget about version control and keeping your Compose file up to date. This will help prevent any compatibility issues and make maintaining your application a whole lot easier. So, when you're setting up a Compose file for your web app, think about breaking it down into separate services. You can have one service for the web server, another for the database, and maybe one more for caching. Each service gets its own settings and dependencies laid out in the Compose file. And hey, here's a cool tip: use environment variables to keep things like database passwords safe and sound. Plus, throw in some volumes to make sure your data sticks around. That way, your app stays secure and can handle whatever you throw at it. Cool, right? So, when you're working with multi-container applications, being able to debug and troubleshoot is super important. You might run into issues like network problems, misconfigured containers, or running out of resources. Luckily, there are some tools you can use to help you out. Docker logs, Docker exec, and Docker events can give you a peek into what's going on inside your containers and help you figure out what's going wrong. Plus, it's a good idea to keep an eye on your application's performance. By monitoring it regularly, you can spot any potential bottlenecks or failures before they become a big problem. This proactive approach can save you a lot of headaches down the road. So, let's say you're having trouble getting a container to start in your application. No worries. Just use the Docker logs command to check out what's going on behind the scenes. This will help you figure out why the container isn't cooperating. Take a peek at the container's setup and make sure everything is in order. Sometimes conflicting settings can cause issues. And hey, don't forget about monitoring tools like Prometheus or Grafana. They can give you real-time data on how your application is performing, so you can catch any problems before they become a big deal for your users. Alright, so when it comes to keeping your multi-container applications safe and sound, securing them is a must. One great way to do this is by using Docker secrets to keep all those sensitive bits of information, like passwords and API keys, under lock and key. This way, you can make sure they're not just hanging out in the open in your Compose file or environment variables. Another smart move is to take advantage of Docker's network isolation features. These can help you control who talks to who among your containers, and even set up some access control rules to keep things in check. And don't forget to stay on top of updates for your containers and dependencies. This will help patch up any security holes and keep your application safe and secure. So, let's talk about how you can keep your banking application secure using Docker secrets. Basically, you can store important stuff like your database password and API keys in a separate encrypted location. This way, no one unauthorized can sneak in and get their hands on sensitive info. And, to make sure only the right containers can talk to each other, you can set up custom networks for each service in your Compose file. This network isolation adds an extra layer of security to your application. Don't forget to regularly update your containers with the latest security patches. This helps keep your application safe from any potential vulnerabilities. Monitoring for any suspicious activity is also key to maintaining a strong security posture.
If you like this video, please like, share, and subscribe to the channel. Until next time.